Hello and welcome to our next section, which is all about arrays. So in JavaScript, arrays are probably the most used data structure. So we use arrays all the time, and therefore JavaScript has countless modern array methods, which we can also imagine as array tools. So in this section, we will learn all about these tools, so how to use them, and even more importantly, when to use them. And we will do that while building our next beautiful project, so that you can immediately apply all these array tools to a real-world situation. So let's go do that. Welcome back. Let's begin this section with a couple of very simple and very easy to understand array methods, just to expand our array toolkit a little bit more. And as always, at the beginning of a new section, make sure to grab your starter files and open them up in VS Code. So that's the folder called Arrays Bankist. And then open up script.js, which is going to contain a lot of stuff here. But for now, don't worry about any of that. I will explain what all of this is and also what else we have in our starter files in a couple of videos from here. All right. So up there we have the application part for the app we're going to build in this section. And then here we have the lectures part, which is a bit more for the concepts themselves. And by the way, this yellow part here comes from a VS Code extension that I use. And I think I showed it to you in the beginning. But anyway, let's not talk about array methods. Now, before we start, let's quickly talk about why arrays do actually have methods. Well, remember that methods are simply functions that we can call on objects. So basically, they are functions attached to objects. So if we have array methods, that means that arrays themselves are also objects. And so these array methods are simply functions that are attached to all arrays that we create in JavaScript. Now, we will learn why all arrays have access to these methods in a later section when we talk about prototypal inheritance. But for now, I just want you to understand that arrays are objects and that they get access to special built-in methods that we can essentially see as tools for arrays. And so, as I mentioned in this lecture, we're going to start by learning some very simple tools that we can use on arrays. So let's start by defining a simple test array that we can work with. And I will make it as simple as possible, just with these letters, because that will help us understand some of the things we're going to do here. All right, the first method we're going to talk about is the slice method. And this one is very similar to the slice method that's available on strings. Remember? So with the slice method, we can extract part of any array, but without changing the original array. So essentially, we can take a slice of an array, and so that's why it's called slice. So array.slice, and now just like in strings, we have the begin parameter. And so this is the index at which we will start extracting. So when we say 2 here, we should start extracting here at C and then all the way to the end. Okay? And then this slice method will return a new array. And so we need to log that to the console in order to actually see it. Okay? So as I said, this does not mutate the original R array. Okay? Instead, it returns a new array, so a copy of the array, but only with the extracted parts. So let's open up a terminal here again, and live server. And here we go. So this is already our Bankist page, but nothing is going to work here yet. So for now, let's just open up the console, because that's really all we are interested in for now. let's reload here again. And so now we indeed get this array, which is a slice of the original array starting at position number 2. So 0, 1, and 2, right? Now, of course, we can also define the end parameter. So when we write 2 and 4, then let's see the result here. And so what this means is that just like in strings, the end parameter here is not included in the output. So index 4 is this one here. And so, yeah, as I just mentioned, this one is then not going to be included in the output. So 2 to 4 is really just 2 and 3. Okay? And so the length of the outputting array here will be the end parameter minus the beginning one. And so that's exactly the length we get here. Okay? Then next, again, just like in strings, we can define a negative begin parameter, and then it will start to copy from the end of the array. So -1 will basically take the last two elements of the array, so D and E. And so with this, it's pretty easy to simply get the last element of any array. So if we just duplicate this, so -1 is always just the last element of any array. So this is a very nice trick that's sometimes useful. And now to make this complete, we can also use a negative index as the end parameter. So let's start extracting at position number 1 until -1, basically. So let's see, that returns B and C, and that's because it now starts extracting at position 1, which is here, and it extracts everything except the last two here. So that's what the -2 here means. All right, and if you find this a bit confusing, then just experiment a little bit more with this. Now finally, we can use the slice method to simply create a shallow copy of any array. So to do that, we simply call it without any arguments at all, and then indeed we get here the exact same array. And if you remember it correctly, we already did something similar in one of the previous sections, but using the spread operator. Remember? So back then we did this, so creating a new array and then expanding the original array into that. And so that gives us the exact same result. So the question is, should you use the spread operator or the slice method in order to create a shallow copy? Well, that's actually entirely up to you. So it's just a matter of personal preference. The only time you really need to use the slice method here is when you want to chain multiple methods together, so calling one after the other. And we will do that, of course, later in this section. All right, so that is the slice method. Next up is a method with a very similar name, which is called splice. And the splice method works in almost the same way as slice, but the fundamental difference is that it does actually change the original array. So it mutates that array. So let's again log the result to the console anyway, but now we use splice, and then with the same argument as we used before here. And so the result here looks exactly the same. So this one here is the same as this first one. Let's give it even more space here. But now, what happened to our original array? And we see that all that remains here in our original array is the first two elements. And so now the extracted elements are actually gone from the original array. So splice deleted them. And so what we can see is that splice actually does mutate the original array. So it takes part of the array and returns it, and then the original array itself loses this part that was extracted. Now in practice, most of the time the value that the splice method returns doesn't even interest us. All we are usually interested in is to just delete one or more elements from an array using splice. And one pretty common use case is to simply remove the last element of an array. So let's actually do that here. So let's say r.splice and then -1. So just like in the slice method, -1 here is the last element. Okay, so the begin and end parameters works exactly the same as in the slice method. Let's now just get rid of this one here so that we see our original array. And so indeed, as we log here r to the console, it is the original array except for the last element, which was e. So that's exactly what we did here. All right. And as always, in case you want to learn more about any particular method, for example, you can always use the MDN documentation. So let's say MDN array splice. So this one. And so now here are some more examples on how to use this. And so you have the name of the parameters. And actually, the second parameter is called delete count. So it's actually not the begin parameter. So it works a little bit different than in the slice method. So let me just show that to you. So going back here. So if we do .splice, let's say at position number 1, and then we want to take exactly 2 elements. And so then we write 2. Okay? And so the result now of the resulting array should be that B and C are deleted. Okay? And so indeed, only A and D now remain. Let's log R to the console here to see the process a little bit better. So here we removed the first one, and then here we went to position 1 and extracted or deleted 2 elements. And so position 1 and then 2 elements. Okay? So this first parameter here works the same as in the slice method, but the second one is really the number of elements that we want to delete. All right. So that is splice. Next up, we're going to talk about reverse. So that's a very simple one. Let's just restore our array here at this part so that we can work with the original one here. Or actually, let's also create a new array here. Let's call this one R2. And here we will have 5 more letters of the alphabet, but this time in a wrong order. So let's say for some reason we are working with this array and we need to reverse it. And so that's exactly what we use reverse for. So R2.reverse, and indeed it now returns the reversed array. Here I actually want F, and so now it is correct. So F, G, H, I, J. But now what's important to note here is the fact that the reverse method does actually mutate the original array. So you see, as we log the original, it is now reversed 2. Okay, so this one here does mutate the array. So that's important to keep in mind. So maybe you're noticing that in each of the methods, I always mention which one mutates and which one does not mutate the original array. And that's because this is a very important characteristic of each of these methods. That's because in a certain situation, we might not want to mutate the original array, and then we cannot use any of these methods. Okay. Next up is the concat method. And so this one is used to concatenate 2 arrays. So let's create a variable called letters. And letters will be the result of calling the concat method on array. And here we have to specify the second array. So let's take a look. And now we have the 10 first letters of the alphabet here. So the first array will be the one on which the method is called, and the second one is the one that we pass into the concat method. And once again, we already did this before in another way, remember? So we could simply also do this, right? R and then R2. This gives us the exact same result, and it also does not mutate any of the involved arrays. So just like concat, which also doesn't mutate the original array here. All right. And finally, just the join method that we already talked about before, but just for the sake of completion here, right? And by the way, here in this concat method, so if you prefer to do this one, it's of course perfectly fine. And once again, it is just a matter of personal preference, whether you prefer to use the spread operator or the concat method. All right. And now here, let's just join all the letters of the alphabet together that we have here in our array by using this separator here. Okay, and so as you already know, the result here is a string with the separator that we specified. Great. So your array toolset is rapidly growing here. And remember that you already know push, unshift, pop, shift, index of, and includes from the intro section. Now, if you ever lose track of all these different methods and how they work, you can always come back to these videos, or of course, check the documentation on MDN, just like we did here. So no developer in the world knows all of this by heart. So sometimes I even have to look up how the splice or the slice method works, because it's just too many methods to keep track of. And yeah, it's very hard to know everything by heart. But anyway, let's now move on to the next lecture, where we will take array methods to a whole new level. There's a new, very simple array method in ES 2022, which is the add method. And so let's take a look at it. And let's start by creating some dummy array. So 23, 11, 64. So just 3 random values here. And then if we wanted to take one of the values out of the array, let's say the first one, then we would traditionally do this, right? So array at position 0. So that's basically what this means. But now with the new add method, we can do the exact same thing using a method. And as you can guess, that is the add method. Then we specify the exact same index here, and then we get the exact same value. So basically now we do what we say here. So here we say array at position 0. And so that's why this new method is called array.addPosition0. So very, very simple, right? So basically we can now replace the traditional bracket notation with the more modern looking add method if we prefer to use array methods like this. Now, maybe this doesn't look all too useful. So what's the big deal here? Well, actually there is one particularity of the add method which makes it quite useful to use instead of the brackets notation. So let's now say that we wanted to get the last element of the array. Now, supposing that we do not know the length of the array, we would write something like this. So array at the position of array.length minus 1. And that will then give us 64. So array.length is the length of the array, which is 3, but the last position here is position number 2, because the array is 0 based. So the indexes are 0 based. So 0, 1, 2. And so therefore, whenever we want to get the last element of an array, we always subtract 1 from the length. So this is quite a common scenario in JavaScript, and that's why there's also another solution. So another way is to use the slice method that we just learned before. So r.slice, and with this we can then get a copy of the original array. And here we can use -1 to get the last element of the array, right? So just like we learned in the previous lecture. So here we get that copy of the array only with the last element. So of course we want the value, and so then we need to take out that first value by doing square brackets 0. All right. So these are the two more traditional ways of solving the problem of getting the last element. However, as you can probably guess, the new add method makes this process even easier. So now all we have to do is to write r.add, and now here we can write the exact same negative indexes that we can write in the slice method. And so if we log this now, then here again we have 64. So the negative index, just like in slice, basically starts counting from the right side here, so from the end of the array. And so we could also write -2. So -1 and -2. So this should give us 11, and indeed, here is that 11. But most of the time, the thing that we're most interested in here is this -1 to get the last element of the array. And that's actually it. Now the only question is, should you use this new add method, or should you keep using the bracket notation? Well, as always, it depends. So if you want to get the last element of an array, or basically start counting from the end of an array, then you should probably start using the add method. Also, if you want to do something called method chaining, which we will talk about later in this section, then the add method is also perfect for that. So basically combining multiple methods all at the same time. And then it's quite helpful to use the add method instead of the brackets notation. Now, on the other hand, if you just want to quickly get a value from an array, so just like the first element, then of course you can keep using the brackets notation. And personally, I also do that all the time. So basically, if all you want to do is something like this, then you can simply keep using these square brackets. Okay. Oh, and by the way, I actually also wanted to let you know that the add method also works on strings. So let's log to the console a string, let's say Jonas, and then here we can also use the add method. For example, let's say at 0. And so that will give us J. And then, of course, we can also get the last character of the string by using at -1. In this lecture, we will loop over an array using the forEach method. Now, we had already learned how to loop over an array using the forOf loop, but the forEach method is really fundamentally different. And from now on, we will start working with our bank account data, but still in a very simplified way. So let me get this data here into the present lecture so that we can see what we're actually working with. So let me comment it out from here and just move it here. So let's say that we wanted to loop over this movements array in order to print a message for each movement in this bank account. So these positive values here are basically deposits, and the negative values are withdrawals. And so we can print something to the console saying whether the user deposited or withdrew some money. And let's actually start by doing this using a forOf loop, just so that we can then compare the forEach loop to this one. So let's create a variable movement of movements, and then we will log something to the console according to the movement value. So basically, if the current movement is greater than 0, then log to the console you deposited and then the movement, and else you withdrew and then the movement again. And actually we can use a nice math function here, which is to take the absolute value. So basically removing the sign. So let's see. And yeah, that looks nice. So of course this solution here works perfect. But now let's finally learn how to use the forEach method to achieve the exact same thing, but in my opinion, in an easier way. So to loop over the movements array, we use forEach, and that's with a capital E, don't forget that. And then the forEach method actually requires a callback function here. So forEach is technically a higher order function, as we learned in the last section, which requires a callback function in order to tell it what to do. So it's the forEach method here that will call this callback function. We are not calling it ourselves, as always. And that's, of course, important to keep in mind once again. But when exactly will forEach actually call this callback function? Well, what the forEach method does is to loop over the array, and in each iteration, it will execute this callback function here. Also, as the forEach method calls this callback function in each iteration, it will pass in the current element of the array as an argument. And so we can specify that here. And let's call it again movement. So again, each time this callback here is called, so in each iteration, it will receive the current element of the array as an argument. And here we can, of course, give this any name that we want, but I'm just calling it movement because that's what we did up here. And so now we can do exactly the same thing here in this callback function. Let's give it a save. And indeed, we now get the same result twice. So let me just add like a separator here for each. And so, yeah, indeed, we get the same result. Can also get ourselves more space. And yeah, so that's essentially how the forEach method works. So basically behind the scenes, in iteration 0, it will call this function here. So an anonymous function in this case without a name. But let's just call it function. And it's going to call it with the value of 200. Then in the next iteration, it will call it with the value of 450. Then with the value of 400, right? And so on and so forth until it reaches the end of the array. And this part of the forEach function passing in the current element of the array, here like this, and this, is especially important to understand. So basically, this is exactly the concept that I explained in the last section when I said that we use a callback function to tell another higher order function exactly what it should do. And so in this case, we tell forEach that in each iteration, it should log one of these two strings here to the console. So we give the forEach method instructions by giving it a callback function which contains these instructions. All right? And I really know and understand that this is quite a hard concept to wrap your head around. But if you just continue using this from now on, then eventually it will start to make sense, believe me. Now, anyway, which of the two versions do you think is cleaner and easier to write and easier to read? Well, I think that we can both agree that it is the forEach method, right? And maybe you don't agree with that. And of course, that's okay. As I keep mentioning, it's always good to develop your own style of programming. But using the forEach method here, and especially understanding the logic behind it here with the callback function, is still really important for all the other methods that we're going to learn later. Anyway, let's now learn some more stuff about the forEach method, because we are not done yet. So what if we actually needed access to a counter variable here? So just like we can access the current index of the array here in the forOf loop. So remember how we did that with forOf. So let's just rewrite this part. So in this case, we loop over movements.entries, remember? So entries is in fact just another array method, and it returns an array of arrays, remember, which in the first position contains the current index and then the value itself. And so this is how we access the counter variable in the forOf loop. And then here in our string, we could use that to say, for example, movement, and then the number of the movement. So that's the counter which starts at 0. And so we just add 1 to that. And so, well, something went wrong. So that's in line 1 to 1. So unexpected token. Oh, and that's because we didn't open it here again. So we were missing this part here. And now this looks a lot nicer with the number of the movement here. And so let's now do the same in the forEach method here. And here, fortunately, it's a lot easier to get access to the current index. So to understand how it works, we need to remember once more that it is the forEach method who calls this callback function in each iteration. And as it calls this function, it also passes in the current element of the array. But actually, that's not all it passes in. In fact, forEach passes in the current element, the index, and the entire array that we are looping. And so, therefore, we can specify them here in our parameter list. So let's say index and array. Now, of course, we can just use one like we have been doing, or we can just use two, or we can use all three together. And as always, the names here do not matter at all, but what does matter is the order. So the first parameter always needs to be the current element, the second parameter always the current index, and the third one always the entire array that we are looping over. Because that's the order in which the arguments, so the actual values, are passed into our callback function. Okay, so now let's just copy this here so we can do the same here, give it a save, and oh, here we called it index and not I. And in fact, in the real world, we actually use shorter names. So let's just call this one I, this one R, and this one here MOV, which is just a shorter abbreviation of movements. And so this is quite a common pattern to just abbreviate a little bit. So let's replace these three here with MOV. Give it a save, and now it does look the same as with the forOf method. But I hope you can see that it's a lot easier to get the current index here in forEach. Just notice that the order of the parameters is different in both these scenarios. So in forEach, the first value here is the current element, and the second one is the index. While when we use here the entries in the forOf loop, then the first element is the index, and the second value is the current array element. So just don't forget that here in this case. So always first the current element and then the index. Okay, and this is how we loop over arrays with the forEach method. Now, when should you use forEach and when should you use the forOff loop? Well, one fundamental difference between the two of them is that you cannot break out of a forEach loop. So the continue and break statements do not work in a forEach loop at all. So instead, forEach will always loop over the entire array, and there is nothing that you can do about it. So if you really need to break out of a loop, then you have to keep using the forOff loop. But other than that, it really comes down to your personal preference, just like so many other things in JavaScript. So every programming language always has many different ways or different tools to achieve the same thing. And especially as more things keep getting added to the language, there will always be more options to achieve the same result. All right, and with this, we wrap up this lecture. So, in my opinion, this is a really brilliant and powerful mechanism, but I know that it's also rather complex to wrap your head around this, isn't it? And it actually took quite some time for me to fully understand this myself. So, back in the day. So please don't become frustrated with this. It will all become obvious with the practice. So just keep using this and then you will be fine. Once you do understand exactly how this works, so especially this mechanism of the callback and of the passing arguments into this callback here, so once you understand this fundamental mechanism, then working with all other array methods in this section will become really easy, because most of them follow the exact same principle of the callback function that we just explored here. So please review this lecture carefully, and yeah, if you really understand the role of the callback function here, then just move on to the next video. See you there. So we learned about the forEach method on arrays. However, forEach is also available on maps and sets. And so let's take a small detour now and see how forEach works with maps and with sets. And we're gonna start with maps, and for that let's cut this currencies map that we have up here. All right. And remember that in this array of arrays, each of these array elements, so this inner array, will be one entry of the map, where this here is the key and this is the value. All right? And so we can call forEach also on a map. So forEach, and then again the callback function. And now this callback function also has 3 parameters. So when the forEach method calls it, it will call this function with 3 arguments. So the first one will be the current value. So the current value in the current iteration. The second one is the key. And the third one is the entire map that is being looped over. And so you see this is similar to the array, where in the array, the first parameter is the current element of the array, the second one is the index, and the third is the entire array. And so there's a nice correspondence between these. And so this is quite easy to memorize here. And so let's just log a very quick string here. So this is not really that important, but I wanted to show you that forEach also exists on these 2 new data structures. Okay, and indeed, it worked. So we got the key of each of the map entries, and then also the value. All right, and so now let's try the same with a set. So this is with a map, and this is now with a set. So let's create currencies unique, let's say. So new set. And remember that in here, we need to pass an iterable. And so I will use an array here. So let's just create a couple of strings here, another US dollar, and then some euros. Let's just take a look. And indeed, it only has the unique values. So just as expected. And so let's now call forEach on this set as well. So currencies unique dot forEach. And now once again, the callback function has the parameters of value, key, and map. And we will see in a second if that actually makes sense. So let's log to the console. Actually, the same thing as here. So let's see what's going to happen. So remember, we are logging the key and the value. Okay? But now we get USD, USD. And here, GBP, GBP. And so what this means is that the key here is exactly the same as the value. So why is that? Well, a set doesn't have keys, right? And it doesn't have indexes either. And so there is no value that would make sense for the key. All right? So essentially this key here makes no sense at all. It wouldn't even have to be there. And so the people who designed this forEach method for sets, they could have simply omitted the second argument, right? Well, if they did that, then this forEach would have been different from the others. And so that would then create confusion in developers. And therefore it was decided to keep the same signature. So basically to keep the same three parameters in this callback function and simply to set the second one to the first one. So we can just write value here as well, just to avoid that confusion. All right. Oh, and of course, we cannot have the duplicate parameter name. And so we can just use an underscore, which in JavaScript means a throwaway variable. So that means a variable that is completely unnecessary. So it's just a convention, which we will see again a little bit later. Okay, and so now it should work. And yeah, that's all you need to know about the forEach method for maps and sets. So it's very straightforward if you already understood how it works for arrays. In this lecture, it's time to take a first look at the application that we're going to build in this section. We will also take a closer look at the starter files for this project, and we will also check out the flowchart for this application. So let's get started. And this is the application that we will build throughout this section and also the next one. So it's called Bankist, and this is here the demo version that is actually live on bankist.netlify.app. So I invite you to actually try out this application together with me as you watch this video, so to get a real good feeling for how it all works. Now this looks a little bit empty, and so you can just basically log in. So write JS, and then the pin is 1111. And so Bankist stands for minimalist banking. And so this is why we have this kind of banking, so an online bank interface. So we have all the movements here. We have the overall balance of the account up here. Then we have some summary data down here. And here on the right side, we have three options that we can do. So we can transfer money to someone else, we can request a loan from the bank, and we can close the account. So let's request a loan here. Let's say I need 1,000 euros. So I click here, and then after some time it is approved, and it appears here as a deposit. Okay, then I can also transfer money, and there is a user called GD, and let's say I want to transfer 5,000. So let's try that. And so now I have 5,000 less than I used to have. Finally, we can also sort these here. So now they are sorted and now they are back to normal. And now let's go to that other account, JD, with the pin of 2222. And so let's check out if she has a deposit of 5,000. And indeed, here it is. We also see that this account here is in US dollars and with the American formatting, while the other one was in euros. And so that's something that we're going to take care of in the next section. But in this section, we will actually take care of displaying all of these movements, making these operations here possible, calculating the statistics, as well as the current balance. And so, yeah, I think it's going to be a lot of fun. And I'm really, really happy with this application. I think it looks amazing. It also looks like a real world use case. And yeah, overall, this is a great project for training arrays because we can do lots of the stuff that you see here on the screen using arrays. Great. So now that you have a feeling for how this application works, let's take a look at a flowchart that I designed or that I built for this application. So here is that flowchart for the Bankist application. And just like before in the pig game, I built this one based on the flow of actions that we just saw in that live version of the Bankist application. So starting there in the top left, as the user logs in, which is one of these yellow actions, so all of these yellow elements here mean some sort of action. So when the login action is performed, we check for the correct credentials, and if they are correct, we display the UI, and then we also update the UI. And so that means to calculate the balance, calculate the summary, display the movements, and then later on in the next section, we will also start and display a logout timer. So all of this here happens right at the beginning as the user logs in. And so actually this part in the beginning here, everything that is inside the update UI will be the first thing that we will do. Okay, then from there we will implement the kind of fake login, and then we will take care of these other operations. So probably we will come back to this flowchart by then. But anyway, this is already a very good overview of all the steps that we have to implement in order to build this application. And you can spend some more time on this and actually compare it to the functionality of the application. That's why, one more time, I included this flowchart in the starter files of this section. Now this time, just like in the pig game, I built this flowchart myself because all that matters here in this project is to build this application and learn all about arrays. But in the next big project, we will actually plan the entire application together, and I will show you all the steps that we have to go through in order to come up with a flowchart like this. So don't worry about designing a flowchart just yet. We will learn how it works and how to plan an application from the ground up. But for now, again, my purpose with this flowchart is just to give us a good overview, so a good roadmap to actually go ahead and implement all the features of this application. And so then whenever we get lost, we can always just come back to this flowchart and see exactly how the application works and what we have left to implement. Okay, but with that being said, let's now go back to our code editor and take a closer look at all the starter files that we have there. So right at the top of our script, we have these 4 account objects. Okay, and so this one here was the JS that I just showed you in the demo. And so here then are the movements stored in that object. We also have the pin, and later on we will also use this interest rate. Okay, now of course in the real world you would want much more data about each of the movements, not just the value, right? For example, we would use the date of each movement, maybe a description, and so on. But here we really just want to work with arrays. And so I'm keeping it very simple, but still at the same time fun to build. Okay. So yeah, so one object for each account. And you could ask, why not use a map instead of an object? Well, the thing is that we're going to pretend that all this data is coming from a web API. So a little bit like we talked about earlier. And whenever we get data from an API, this data usually comes in the form of objects. And so this is why we have objects here. And then finally, an array containing all these account objects in there. Remember that this is one of the most common ways of organizing data in JavaScript applications. And so that's why we are going to use it throughout this section to make this actually feel a bit more like a real-world application. All right. So that's the data. Let's take a look here a little bit at the other files. So as always, we have the prettier configuration. Then here's the flowchart that I just showed you. And so here you can take a look at it by yourself. Then the index.html, and this one is a lot more complex now, and we will actually need it to take some code out of there. Then here we have the icon and the logo. So like this icon you see here in the tab, so the fav icon. And finally we have the style. And so here you can have some fun and learn some CSS if you're interested in it. So it's almost like 300 lines of code, I think, that I built to style this application. So you see, I really put a lot of work to make this application really fun. Okay. So I think that's it for the starter files. Just notice that I already selected all of the elements that we're gonna need. So you see, it's a lot of stuff, and I'm gonna explain what each of this is. But what matters is that this way, we don't have to write all of this code ourselves. And so this makes development a little bit faster. So a lot of elements here. And yeah, so I think that's it for this video. I think you got a good overview of this project for this section. And once again, please go ahead and take a look at this URL by yourself and use user.js and pin 1111. And then when you're familiar with how the application works, then let's move on. In this video, we're finally gonna be back to DOM manipulation. And we're gonna learn a couple of DOM manipulation techniques, and we will use them together with the forEach method that we just learned about. So this is really exciting stuff, so let's get started. And to start, let's actually open up the HTML and CSS files, and we will then keep them open here throughout this project. And I like to have the script always the last. Now in the HTML, we have this navigation bar, so this nav element, which is all of this top part. And then after that, we have the main element. And so that's basically the entire application. And that part is right now invisible. And so that's because here in the CSS, so in line 87, we have the app selector and the opacity is set to 0. And so we need to comment that. And for that, we can, as always, use command / give it a save, and then we can finally see the application here. All right. So logging in and out of this application is essentially just changing this opacity here. And so now the opacity is basically back to 100 because now we commented it out. And so 100 is the default. But anyway, let's go back to our script here. And so what we want to do now is to basically display these movements right here in the application, here in this list. So in this container. So for each movement, we want one element like this, okay? And we will be able to do that because of the forEach method, which will allow us to loop through this array, and then in each iteration, basically create an element like this and display it on the page. So this time, we're finally gonna move away from the console and actually do some DOM manipulation here. All right, so let's move down here after these elements, but still inside of the app part of this file, and then let's write our code. Now we could simply start writing our code out here in the global context. However, that is not a good practice. So whenever we do something like this, it's always best to create a function. So let's call this one print or a display. I prefer display. So display movements, and then we make this function receive the data with which it should actually work. So in this case, that's the movements. So we call this parameter movements because this function should receive one array of movements and then work with that data. So in this case, that's the movements that it should display in the user interface. All right. And so it's a good practice to pass the data into a function instead of, for example, having this function work with a global variable. That would work as well, but it's a lot better to pass that data directly into the function. Okay, so get used to that kind of approach. All right. So again, instead of working with global variables, start passing the data that a function needs actually into that function. So let me, as always, call this function first to see what we will get as an input. And so the movements that I will use here will come from this account1. So essentially, that's going to be this array. So account1.movements. So account1.movements. Okay, and so inside of this function, these movements are simply called movements. And so now let's loop over these movements using what we learned before. So for each, and then our callback function here. Now inside of this function, we need the current movement, and we also need the index. And that's because here actually I have them here number 1, number 2, and so basically we have the movements numbered like this. Okay, so starting with the first movement down and then adding the new ones on top. Okay, all right, so that's the easiest part. Now we have to essentially create an HTML that looks like this. So let's go to our HTML file and to actually take a look at what this HTML looks like. So we are inside our app element here basically. Then we have this movements element, which is all of this container here. And maybe it would be easier to actually see this in the console. So if we did this, maybe we can get rid of this part. Not really. But anyway, now we can see that all of this is the movements. And then in each movement, we have a movements row. So each of this is a movements row. Okay. And so let's now copy the entire code of one movements row, because this is what we want to create in each iteration of the loop with the current data. So essentially, let's take all of this. So I'm going to copy it and let me now paste it here into a template string. So I will create a variable which I'm going to call HTML, and then I'm creating a template literal. And template literals are amazing for creating HTML templates like the one we will create now. Because now it's really easy to create a multi-line string like this. Okay, let's just fix indentation here a little bit to make this then easier to understand. Okay, and now all we have to do is to basically replace the data that is not relevant, so this hard-coded data, with our actual movements data. Okay, now this part here of the date we will not do now. We will take care of this in the next section. So let's get rid of it. And then here we have the movements value. So this is formatted, but again, we will just use the plain value that's coming out of the array for now. And so now we can simply insert that here. And so that's mov, right? So mov is the current element in the array that we are looping over. And so in each iteration, that will then be one of the movements in the array. Then here we have to deposit. And so we will have to check whether a certain movement is a deposit or a withdrawal. So let's delete that. And for now, we can add the number here. So you see 1, 2. And so for that, we now use the I. And so that's why we also needed the current index besides just the current value. Okay. And now we need a way to knowing if it's a deposit or a withdrawal. And so let's use a ternary operator, and let's do that out here as a separate variable, because we will need that twice. We will need it, one, to write it here on the user interface, but here also this class name depends on that. So you see that we have type deposit, so that's then this green color, and we have type withdrawal, and so that's then this red color. So we will need this information twice. And so let's just calculate it outside here. So I'm going to call it type. And so this is the same logic as before. So if the current movement is greater than 0, then the type should be deposit, or else it should then be withdrawal. Okay. And now let's write that here. So the type here, and again also here in the class name. So we can also basically construct this class name here, which is very useful too. And I hope here you can see that the template literal is really a lifesaver here. Okay, so we created our HTML template here. Now all we need to do is to find a way to actually adding this HTML onto the web page here. So we need to attach this HTML somehow into this container. So into this movements element, okay? And to do that, we will use a method called insertAdjacentHTML. So that's gotta go right here. So let me first write the name of the method, and then I'm going to tell you where we actually have to attach this method to. So it's called insertAdjacentHTML. And we are going to call this method on this movements element here. So this container onto which we want to add a new movements row element. So this element here on which we want to add a new movements row. Right? So we are looking for an element with the class of movements, and as I told you in the last lecture, I already selected all of these elements. And so in this case, it's this one, and so the name is container movements. Okay, so you see that I used kind of uniform names here. So I have container app for this entire application container and container movements. Then all the other ones are called label, so label welcome, date, and so on and so forth. Then the others are called button, and then all the input fields are all called input, and then whatever the name of them. So to keep it nice and easy to understand. But anyway, this one is called container movements. And so onto there, again, we call insertAdjacentHTML. And this method accepts two strings. The first string is the position in which we want to attach the HTML. And this one I'm going to set to after begin, but there are more options. And I think the best way of showing it to you is actually in the documentation. So MDN. And so whenever I need to figure out something, this is how I do it. So I know that down here there is a visualization, and yeah. So these are the four options here. and the one we chose is after begin. So that's this one. So imagine that this P element here is our container movements. And so basically I want to add new elements right after the beginning of this element. And so basically I'm saying here that I want to insert the new child element right after the beginning of the parent element. So again, that's container movements. Then we have before end, which is at the end of the element, as the name says. And then we can even put it outside of the parent element. And then we could even put it outside of the container movements. And sometimes this is useful as well. But usually I always use after begin or before end. And once we see the result, I will explain a bit better why it is after begin and not before end. But anyway, let's go back here, because now we need to specify the second argument. And that is the string containing the HTML that we want to insert. And that's it. So if we now run this, it should already work. And yes, it does. So that's amazing. And let's check it out. And let's compare it with our values. And so indeed, the newest one is the last one here. And so that's element number 8. And it is indeed 1300, right? And it is indeed green because it is a deposit, so a positive number. The same with the 70, and then we have minus 130. And so indeed, that's a withdrawal. Beautiful. Now, if we scroll down here, we will see that we still have these two old ones. So basically the two that were already there. And that's because all we are doing is to add new elements to this container. Right? We are only inserting new HTML here inside of the container movements, but we are not overriding anything. And so actually that has to be the first thing that we do. So the first thing is to essentially empty the entire container, and only then we start adding new elements. So that's something common to do, and it is also not difficult at all. So container movements, and now we can use the inner HTML property, inner HTML, and set it to the empty string. And that's it. So this fixes our problem. All right. Now inner HTML here is a little bit similar to text content. So remember that. Now the difference is that text content simply returns the text itself, while HTML returns everything, including the HTML. So all the HTML tags will be included. Okay. But here we are then using inner HTML as a setter. So just like we also used text content equal empty string or equal something else. Remember? So we used to do in our pick game, for example, like whatever and then text content and then set it to 0. Remember that? But as I said, we can also use this to read data. So let's simply log to the console just to understand this property, which is pretty important. So after all this, let's do container movements.innerHTML. So we're simply reading the inner HTML and then logging it to the console. So console, and indeed, here you see all of this HTML. All right. So essentially, that's the HTML that we just created. Okay. But let's get rid of this. I just wanted to show you both sides or both applications of inner HTML. All right. And finally, I wanted to show you why I used after begin and not before end. Well, let me show you what would happen with before end. I think this is how it works. So before end. Yeah. So with that, the order of the movements would be inverted. Okay. And that's because each new element would simply be added after the previous one. So at the end of the container, right? And so that's after all the child elements that are already in there. And that's why I wanted it to be the other way around. Because like this, it will always be basically appended to all the other children. So any new child element will appear before all the other child elements that were already there. And so now we are back to the order that we wanted here. All right, that's amazing. So we completed the first part of our user interface here already, and all with the power of the forEach method. And then also we introduced some new concepts. In particular here, the insertAdjacentHTML method, and then the inner HTML property. Now, there are many other ways of creating elements in JavaScript besides this one here, and we're going to study all of them in great detail in a future section. But this here is actually the one that I like the most. It's the easy, quick and dirty solution, so to say. So all we have to do is to create a string of HTML, and then we can insert that simply with this method. So very simple, very straightforward. So this is some great DOM manipulation that we did right here, and I'm really happy about the result that we got here in our application. Great, so let's now move on. Welcome back to the first coding challenge of the arrays section. And in this one, Julia and Kate are doing a study on dogs. So each of them asked 5 dog owners about their dog's age, and then they stored that data into an array. And that's one array for each of them. All right? And in this study, they are interested in knowing whether each of the dogs is an adult or a puppy. And the rule is that a dog is an adult if it is at least 3 years old, and it's a puppy if it's less than 3 years old. And by the way, the test data here, so the arrays for each is down here, so test data 1 and 2. All right. So your task is to create a function called checkDogs, which accepts these 2 arrays and does the following things. So first, Julia found out that the owners of the first and the last 2 dogs do actually have cats and not dogs. So here, what I want you to do is to create a shallow copy of Julia's array and then remove the cat ages from the copied array. And you should copy it because it's a bad practice to mutate the parameters or the arguments of a function. Then, second, create an array with both Julia's and Kate's data. So for Julia, of course, the corrected data. And then for each of the dogs, simply log to the console whether it is an adult with a string like this or a puppy and then with a string like this. And that's, of course, according to the rules in the beginning. And then just run this function for both test data sets. And that's it. So all you need to do is to use the tools from all the lectures in this section so far, and then I think you will be fine solving this on your own. So this is really all about using the tools that we already learned before, and there's not a lot of new thinking to do here. So I hope you managed to do this one, and I see you back here in a second. All right. So hopefully you did this just fine without any problems. But I will anyway write my solution here and explain what I'm doing. So we accept the docs from Julia and the docs from Kate. And we will call this with the test data. And so Julia's data is this. And there's not a need to store them in separate variables. I will just call the function like this. All right. And now we should create a shallow copy of docs Julia so that we can then remove some elements from there. So docs Julia corrected dot slice. And so I'm using here the method and not the spread operator. And now I will simply remove some elements from there. So docs Julia corrected dot splice. And so it tells us that the first and the last two docs are not valid, basically. So the first is element number 0, and then we want to remove 1. So that's the first part. And then docs Julia corrected dot splice, and then the last two, which is -2. Okay. So let's take a look here simply at docs Julia corrected, just to see if this is correct, actually. So we need the console now. And so this was our beginning data. And indeed, the first and the last two are gone here. All right. Now, of course, you could have also done this in a different way, which is to simply copy the correct data from the original using the slice method. So something like this. Docs Julia dot slice. So starting from the second one and then all the way to the third one. Okay, and so this would give us the exact same result, but in this case, I just wanted to use the splice method. And in fact, I wanted you to use the splice method as well, and that's why I gave you that task like that. Anyway, we don't need this here anymore. Let's now simply create a new variable with both these docs. So simply calling it docs. And again, we could use the spread operator here, which I actually prefer. But since we are in the arrays section here, let's do everything with array methods. So that's the concat method, remember. And then we want to join the corrected Julia docs with docs Kate. So always a good idea to check. And yeah, that's correct. All right. And so all we have to do now is basically create this string. Let me just copy this string. And so looping over this array is now an easy task, hopefully. So docs.forEach, then the callback function. And one more time, we need actually the current element and also the index. And that's because here is the number, so doc number 1, and it's going to go all the way to 7. And so let's check out our rule. So a doc is an adult if he is at least 3 years old. So if doc is greater equal 3, then log a string like this. So here is the index plus 1. Here goes the dog itself. And then else is still a puppy. And here we need just this. And I think with this we are good. Let's just remove this. And yes, dog number 1 is 5 years old, so it's still an adult. Number 2 is 2 years old, so still a puppy. This is again a puppy with 1 year old. And so, yeah, that's the correct solution. Now let's just do it for this test data here. Then I'm gonna duplicate this one. Let's just comment out the first one. And okay, here we only have one puppy, which is the one before the last. And so this one is correct as well. And so, challenge completed. In JavaScript, there are three big and important array methods that we use all the time to perform data transformations. So basically, these are methods that we use to create new arrays based on transforming data from other arrays. And in recent years, these tools have become really popular, and for good reasons, and therefore you will see them everywhere you look in modern JavaScript. And the tools I'm talking about are map, filter, and reduce. So these are three array methods, and in this lecture I'm going to give you a quick overview of them. Then, over the next couple of lectures, we're going to dive deep into these three methods in practice so that we can use them throughout the rest of the course. First, the map method is yet another method that we can use to loop over arrays. So map is actually similar to the forEach method that we studied before, but with the difference that map creates a brand new array based on the original array. So essentially, the map method takes an array, loops over that array, and in each iteration, it applies a callback function that we specify in our code to the current array element. So in this example, we say that each element should be multiplied by 2. And with this callback in place, the map method multiplies every single element by 2 and puts it into a new array. We say that it maps the values of the original array to a new array. And that's why this method is called map. And it is extremely useful, usually way more useful than the forEach method, because forEach simply allows us to do some work with each array element. But map, on the other hand, builds us a brand new array containing the results of applying an operation to the original array. Alright, and we will use the map method in practice right in the next video. Anyway, next up we have the filter method, which, as the name says, is used to filter for elements in the original array which satisfy a certain condition. So in this example, we're only looking for elements greater than 2. So only elements that pass the test that we specified will make it into a new filtered array. Or in other words, elements for which the condition is true will be included in a new array that the filter method returns. All other elements will get filtered out, so they will not be included in the new array. And finally, there is also the reduce method, which we use to boil down all the elements of the original array into one single value. And an example of this can be to add all the elements of an array together, but we can also do many other interesting things. So for the example of adding up all numbers in the array, we need to specify an operation like this one, where we have an accumulator variable. Then, as the reduce method loops over the array, it keeps adding the current element onto the accumulator until, at the end of the loop, we have the total sum of all the elements. So you can imagine this as a snowball that keeps getting bigger and bigger as it rolls down a hill. And so this is known as the snowball effect, and reduce is pretty similar to that. Okay, so keep that in mind as a nice analogy. Now we also say that this whole process has now reduced the original array to one single value, which in this case is the sum of all the elements, but it can of course be many other operations. Now it's this value that then actually gets returned from the reduce method in the end. So there is no new array in this case, but only the reduced value. Now this probably sounds more complicated than it actually is, and so let's start to put it into practice right in the next video. Let's now start seeing the three data transformation methods in practice, starting with the map method in this video. And as we just learned, the map method is yet another way that we can use to loop over arrays. But unlike forEach, the map method will give us a brand new array. And this new array will contain in each position the result of applying a callback function to the original array elements. So let's see how that works. And let's start by bringing back our movements array here. So this one, so we will once more work with these movements. And in this one, we will try to convert them to US dollars. So let's suppose these movements are in euros, and we now want to convert them to US dollars. And let's suppose that 1 euro is worth $1.1. So let's just store that conversion rate here first to a separate variable. So euro to USD is 1.1. And so now what we want to do is to basically multiply each element of the movements array by this 1.1. So let's say movements.map, and then just like in the forEach method, we need a callback function. And this callback function also gets as an argument the current array element. So again, just like in the forEach method that we studied before. And that's why I said back then that once you understood the forEach method, all the other methods will then become a lot easier to understand. So let's call this one here mov one more time. And then here in the callback function, we need to return the value that we want the new array to have in the current position. And so in this case, we want the original array times the euro to USD conversion rate. And this will make sense when we now see this result. And so let's actually store it to a variable. So we already know that the map method will return a brand new array. And so we need to store that somewhere. So let's call it movements USD. And then let's log both to the console movements and movements USD. Give it a save. And sometimes we need to reload the page as well. But anyway, here is the result. Now, never mind these multiplication errors here. I will explain you a little bit later where they come from. But essentially, this new value here is now 220, which is exactly 200 times 1.1. And so indeed, we ended up with a new array containing all the movements, but converted from euros to US dollars. And again, that's because that is exactly what we returned here from this callback function. We could, of course, have returned simply something else. So we could have returned simply 23. And so what do you think we will end up in this situation? Well, we now simply have an array of the same length, which in each of the position contains 23, because that's what we returned from the callback function. And so in each iteration of the original movements array, it simply put 23 into the new array at the same position. But of course, that's a little bit useless. And so let's go back to the example that we're working with. Great. And of course, you can also see that the original movements array was not mutated at all, right? And so indeed, the map method really only returns a new array with the new elements. And this really is the fundamentals of how the map method works. So we can use this, and we will use it in all kinds of different situations. Now, just for fun, let's write the same thing here using a for-off loop. So we can create another mov, and then we are looping the movements, of course. And so in this loop, we want to create a new array. And so in this case, actually, we first need to create that new array. So let's call it again movements USD, but then for. So here we first need to define that empty array. And then as we loop over movements, we keep pushing a value to the new movements USD for array. So push and the current element times euros to USD. Let's log that as well, and it should look exactly the same. And in fact, it does. And so, yeah, we could have written this here, and it doesn't look too bad either, but it's a completely different philosophy. So here, in the map method, we use a function to solve this problem of creating a new array. While here, we simply loop over one array and then manually create a new one. So these are completely different philosophies, or we can also say paradigms. So this here is more in line with functional programming, which is something that I have mentioned a couple of times in this course, and we will talk about it later in greater detail. And in modern JavaScript, there's definitely a push going on in the direction of functional programming, so of a more functional language, and therefore in modern JavaScript, this here is the way to go. So using methods together with callback functions like this is the new and modern way of doing stuff. All right, but now let's actually make our callback function here look a little bit cleaner. So this callback function, we can simplify it greatly. So do you remember arrow functions? We could perfectly use an arrow function here and simplify this here into just one line of code. So here is my challenge for you. Do you think that you can do that yourself? So basically replacing this callback with an arrow function. Take a minute and see if you can do that for yourself, and I'll see you back here in a second. So let's just copy this and then replace this by parts. So first we can remove the function keyword and then replace it with an arrow. Then we can also remove these parentheses here because there's only one argument. And finally, since we only have one line of code, we can remove the curly braces, and we can even remove the return statement. And so this code that we have here now is exactly the same as before. So we can comment out this one here. And of course, I'm leaving it here for reference. But as I save it now, you see that the result is exactly the same. And so here we now have a nice and clean one-liner callback function just like this. However, many people don't like the way that this looks. So they argue that this lacks the function and the return keyword, which they say leads to bad readability and that it makes this whole thing more difficult to understand. And while I can see that that might be true, I actually do prefer the fact how much smaller and cleaner this code is. So in my opinion, if you understand well enough how the arrow function actually works, then you will become familiar with this pretty quickly. And so then there is no problem in writing code like this. Okay? The main thing that you need to keep in mind is that here we are actually returning this value. So you need to remember that this is like writing return here. And so if you understand that, then you're good to go. So I will actually use arrow functions in these situations in the rest of the course, because I believe that they are perfect for these small callback functions. In my opinion, they were really developed for this kind of application. But as always, if you do prefer the regular function syntax, then please feel 100% free to keep using them instead. And with that being said, let's now experiment a little bit more and explore the map method some more. So just like the forEach method, the map method also has access to the exact same three parameters. So besides the current array element, which is this one here, we also get access to the current index as well as the whole array. So let's now use the map method to loop again over the movements array, but this time we're going to create a string similar to the ones that we printed to the console earlier using forEach. So let me actually get that logic. And so it's this one here. So let's specify a callback function. And indeed, now I will actually use an arrow function. And so, as I said, we get access to the current element, but also to the index and to the entire array. This time we do need a block, at least for now, and then here we have our logic. Now in this case, we will not log something to the console. So instead, we want to return the string so that it then gets put into the new array that results from the map method. So let's say here, movements descriptions. So that's a long name. But anyway, again, here we do not want to log something to the console. So we don't want to simply do something with this value like we do when we console.log. Instead, we really want to return it. And so that will then place this value into the new array. So let's save that. Let's then also log this to the console, movement descriptions. And so indeed, we get this array with these strings that we previously logged to the console. And by the way, it's completely acceptable to have two return statements or even more in the same function, as long as only one of them is executed, right? So in this case, either this one here is executed or this one. It's impossible for both of them to return at the same time, right? And actually, we can even simplify this whole thing here, because these two strings are essentially the exact same thing, except for this word here. And so let's do something else here, right? Now you also have this math.absolute value, but if the value is already positive, as it is here, then that simply makes no difference. And so let's use a ternary operator here to put either withdrew or deposited right here. And so this has nothing to do with the map method, but yeah, it's a good way to also keep practicing the other skills that we have been learning. So we can check if the movement is greater than 0, so the same condition as here, and if it is, then at this part of the string, it should say deposited. And if not, well, then it should say withdrew. And so like this, we built this string all in one go. And so we can get rid of this, we can get rid of this, and so therefore we don't need the return keyword anymore. And so it works just the same. Okay? Now in this case, we don't need this array here, so let's actually also get rid of it. And it's a good idea to keep in mind why we actually get access to these two parameters here. So one more time, all we do here is to pass this callback function into the map method, right? But we do not call this function by ourselves. It is the map method who will call this function for each of the array elements in the movement array. Okay? Now, each time that the map method calls or callback, it will simply pass in the current array element as well as the current index and the whole array. And of these three, here we are only using the first two, just the current element and the current index. All right. And with this, I hope that by now it is really crystal clear how this all works. Now you could say that what we did here with this map method is essentially the same as what we did with the forEach method. But in fact, there is a big difference between these two approaches. So before, we printed each line individually to the console as we were looping over the array. So in each of the iterations, we performed some action that was then visible in the console. And we can call this a side effect. So the forEach method creates side effects. But now, here with this map method, all we did was to return each of the strings from the callback. And so basically they got added into a new array. And then finally, we logged that entire array to the console and not the elements one by one. And so here, in this map method, we did not create a side effect in each of the iteration. All we did was to build a brand new array. And this idea of side effects will become important again as we talk more about functional programming. Great, and this is how the map method works. In the next video, we will see a more practical application of it in the context of our Bankist application. Let's now use the map and the forEach methods to compute usernames for each account owner in our application. So we have these 4 accounts, and for each of them, we want to basically compute a username. And the username is simply the initials of each of the users. Okay, so let's just start with one of them, just with one string to make it really easy. And then we will generalize that function for the entire accounts array that we have down here, so which contains all of the accounts. But for now, I will just grab this string here and create a username for this one. So let's do that down here after this first function that we created. And for now, we will do this outside of a function just to see how it works. And then afterwards, we will create a new function. So let's say the user is this one here, and we want to compute the username. So for this one here, the username should be STW. So that's just the initials in lowercase. And so let's do that. So we start by transforming this string to a lowercase. So we already know how to do that. And now we simply want to take the first letter of each of the words. All right. And so we need to basically split up this string into the multiple words. So this is a very common use case for the split method. So dividing by spaces, which will divide the string into words. And let's just take a look at what we have now so that we can discuss our next move here. So username. And so right now we have Stephen, Thomas, and Williams. And so how do we take each of the first letters here? Well, we could simply loop over the array and then take the first letter in each iteration and add them into a new array. And then in the end, we would join that array and we would end up with just a string of STW. Okay, so let's do what I just said. So looping over this array, taking the first letter and then putting it into a new array. And that is exactly what the map method does, right? Now we can do that directly here because this split method here returns an array. And we can then call the map method on that resulting array. So we can immediately do .map here, just like we can call the split method on the result of the toLowercase method, because this one here returns a string and split is available on all strings. Okay, so let's define our callback function here. And I will start by doing it with a regular function. And so here, let's say we get a word or a name. It doesn't really matter here. And so in each iteration, what we want to do is simply to return the first letter. So that's name at position 0, right? And so right now, this should be an array with only these 3 initials. So let's see. And yes, beautiful. That worked just fine. And so the result of this here, of this whole thing, is now an array. And on an array, we can call the join method. So .join, and simply by an empty string, and this will give us the final result of STW. All right, great. Now let's simplify this callback function here. And again, I will start by deleting the function keyword. Then we can also delete the curly braces. And finally, also delete the return. And so see how simple this has become now. So we transform name to name at the first position, so just the first character. And one more time, don't forget that this is actively returning here. We just don't see it, okay? But the return is happening. And this is the reason why this works, because the callback function in the map method always needs to return the new value that should be in the new array. All right, so this works great with this username. Let's now take this actually into a function. So I'm cutting it here. And let's say create usernames. Create a function. Add this here. And for now, let's say we get the user in here. And so now we can call the function with this string. Oh, and here I called console.log instead of create username. Okay. And yeah, if we want to see the result, we would also have to log it to the console now. So of course, first returning the username and then log it to the console here as well. And so indeed, we now get the same initial that we had before. But now we actually want to compute one username for each of the account holders in our accounts array. All right. So to do that, should we use the map or the forEach method? Well, we do not want to create a new array in this situation. All we want to do is to modify the objects, so the elements that already exist in the accounts array. So in this array here, right? And so what we want is to simply loop over this array here and then do something. And so for that, we use forEach, all right? So let's modify this function here some more. And instead of simply receiving one user, what we want to do is to receive all the accounts. So basically an array of accounts. And this goes back to the philosophy I explained to you in the last lecture, which is that each function should actually receive the data that it should work with instead of using a global variable. So that's exactly what we did here with the movements, which we could have read directly from the global variable of account1.movements, for example. But instead, we created a function that receives that data and can then work with that data or with any other data that we choose to pass into it. And so here we are doing the same. We do not want to rely on the accounts array that we already have, but instead we want to pass it into the function. Let's get rid of all of this. And so what I mean is to actually pass the accounts array in here. And here it doesn't have to be called accounts. Let's just call it like this as an abbreviation. Okay, just to remove a little bit the confusion that you might have. Okay, and now as we were saying, we need to use the forEach method here because again, we do not want to create a new array. We simply want to modify basically the array that we get as an input. And this is a really important distinction to keep in mind. So here we are again talking about the side effects that I mentioned in the last video. And in this case, the side effects are going to be to change, so to mutate the original accounts array. And so that's what we want to do here. And so forEach is the way to go. So for each account in the accounts array, so I'm just calling this ACC, which is again an abbreviation for one single account. So for each account, we now want to do this here, basically. So let's grab all this. We can remove this. And so let's create a new property on each of the account objects. So account.username, and that will be equal to user.owner, owner. And so let's check out why that is. So each of these accounts has the owner property. And so that's where the name of the owner, so of the user, comes from. So we take that, so account.owner, and create our username from that. Okay, so that's what we do here. And then we create a new property on that account element. And yeah, and that will then contain the username that we create here. Okay, here we have some kind of error. And of course, it's not user, it is account.owner. And now that's it, right? And in this function, we do not return anything because, again, what we're doing here is to produce a side effect. So we are doing something to this account object here, and so there's no need to return anything. We are just doing some work here, basically. We are not creating a new value to return. Okay? Now, if we want to see if this actually worked, we can log this accounts object or this accounts array to the console. And so in there, we should now see our objects with a new property. And indeed, we get the username of JS. And this one should be JD. And here our Stephen Thomas Williams. And indeed, it is the STW that we had previously worked with. Okay? So in this lecture, it was very important to understand the use case for the map method here, which was perfect because it allowed us to create a new simple array which only contains the initials of whatever name it is used on. And then, on the other hand, the forEach method was a great use case to produce some so-called side effects. So in other words, to simply do some work without returning anything. And so that's what we did here. We simply looped over the accounts array, and in each iteration, we manipulated the current account object and added a username to it based on the account owner, plus all of these transformations that we had already done before. So a couple of interesting and important takeaways from this video. So make sure to review it properly, and then let's move on to our next transforming method, which is the filter method. Now let's learn about the filter method, which, as we learned before, is used to filter for elements that satisfy a certain condition. And how do we specify such a condition? Well, you guessed it, we use a callback function again. So let's again work with our movements. And so now the filter array. And once again, I will start with a regular function. And just like the other callback functions, like in map and forEach, this one also gets access to the current array element as well as the index and the entire array. But let's only work with the current element here, which in filter is usually all that we need. Okay, now what we want to do here is to create an array of the deposits. So let's actually write that. So deposits. And deposits are only the movements that are above 0. So we already know that, right? Let's indeed take a look at the movements here. So here there are. And so we want to filter out these negative values. And so that condition is so that only the values that pass the condition will then make it into the new array. And passing that condition means that it's true. So we will again return something here. And here the trick is that we return a Boolean value. And so in this case, all we need to do is to say the current movement greater than 0. And that's it. And so now only the array elements for which this condition is true will make it into the deposits array. All the other ones will simply get filtered out. So they will not be included in this deposits array. Okay, and in fact, we only get the positive values now. Beautiful. And that's actually it. That's really simple, right? So just as I told you, if you know how to use the callback function correctly, and if you know how and why it works, then all of these methods become really, really simple. And once more, I also want to use the for-off loop here again, so that you can appreciate the difference. And that's very simple. So we need, of course, the same condition. So if the current movement is greater than 0, then we want to push the current element into a new array. So we need to create that here, deposits for, and start again with an empty array. And so in this case, we simply push it there. So we push the current movement. And so let's take a look now. And as expected, we get the same result. And so you could again ask, what is the big difference here? Like, what's the big deal? And why not just use the for loop for everything? And the reason for that is, again, the push that exists in JavaScript for using more functional code like this. But there's also a more practical implication here. And that's because we can actually chain all of these methods together. So basically use them all one after another to build a big final result. So a bit similar, in fact, to what we did here in our application right here. But here we mixed string methods with array methods. But later on, we will do like big chains only with array methods. And that would be completely impossible using the for loop. So that's another big advantage of using the methods instead of the regular for loop. Now, anyway, I have just another small challenge for you here, which is to create an array of the withdrawals. So withdrawals like this. So I want you to create this array without looking at the code we already wrote. And so the withdrawals should only include the negative numbers here. So pause the video now for a minute and please try to write this code on your own. Okay, so hopefully you did that. And so it is movement and again dot filter. And now I will use an arrow function here. So I will leave this one with the regular one and now an arrow function. Okay, and now mov less than 0, and that's it. This is our condition, and never forget that this one is actually returned here. So again, it is like having return written here. And so this is why this works. Let's log it to the console. And yeah, only the negative numbers remain now. All the positive ones got the result of false here in this condition, and so therefore they were not included in the withdrawals array. And again, these callback function here also get access to the current index and the whole array. And I will just leave it here, but I never used these in my life ever in the filter method. Okay, so this was the second of the data transformation methods. So that's map, filter, and reduce. And so in the next video, we will then talk about reduce. In this video, we're going to talk about the third data transformations method, which is the reduce method. And as you remember, we used the reduce method to essentially boil down all the elements in an array to one single value. And we talked about the example of adding up all the numbers in one array, right? And so let's try that now with our movements array. And remember that array looks like this, okay? And then by adding up all these numbers, so both the deposits and the withdrawals, we end up with the global balance of the account, basically. So let's start using the reduce method here. And so as I just said, we're going to call it on the movements array. And the result of the reduce method will be, as I just said, the global balance of the account. So let's call the result balance. And remember that in this case, this balance will be simply one value and not an entire array. Okay, so the reduce function also gets a callback function, but this one is a little bit different from the other ones, like the one in map or forEach. So in these other callbacks, the first parameter is always the current element of the array. Let's call it current. The second one is the current index, and the third one is the entire array. But here in the callback function of the reduce method, the first parameter is actually something called the accumulator. So let's call it ACC like this as an abbreviation of accumulator. And this accumulator is essentially like a snowball that keeps accumulating the value that we ultimately want to return. So in the case of adding all the elements or all the numbers of an array together, that will be the sum. So let me write that here. Oops. So let me write accumulator is like a snowball. All right. But anyway, let's now write the actual function block here. So as always, this callback function here will be called in each iteration of looping over the array. So reduce also loops over the array and calls this callback in each iteration. But now, what will we actually do in each of these iterations? Well, since the accumulator is the value that we will keep adding to, what we're going to do here is to add the current value to the accumulator. So the accumulator plus the current value. Okay? And this works because in each call of the callback function, the accumulator will be the current sum of all the previous values. And so we will really keep adding to this accumulator in each iteration of the loop. Finally, we also need to return this value here from the callback. And so this is how the new accumulator can then be used in the next iteration of the loop. So basically, in each loop iteration, we return the updated accumulator, so the current one, plus the new current value. And so like this, we can then keep adding to it in the next iteration. Okay? So this callback function is the first argument of the reduce method, but the reduce method actually has another, so a second parameter. And that is the initial value of the accumulator. So the value that we specify here, which in this case is going to be 0, is the initial value of the accumulator in the first loop iteration. And so in this example, we want to start counting, or we want to start adding at 0. And so therefore, we simply specify 0 here. Okay, and with this, we should be able to already take a look at our balance. And yeah, so we have one single number. So indeed, everything was reduced, was boiled down to this one number, which we can suppose is all of these values here added together. All right. And to make this even more clear to see, let's actually always log the accumulator to the console. So let's say iteration number I, and then the accumulator in there. Okay. So we see that in iteration 0, the accumulator is 0. And so this is the value that we specified here as the starter, so as the initial value. Then in the second iteration, the accumulator is already at 200. And that's because that is the initial value plus the current value in the previous iteration. So that was 200 there, right? And so this 0 plus the 200 creates the new accumulator, which is then in the next iteration 200. Then in this iteration, we add the current value again, which is 450. So that result is 650. And therefore, in the next iteration, that's the value of the accumulator. Okay, and so here you can really see like the snowball effect of all of these values adding up to one final value. And in the end, that value is essentially the accumulator. Now here we see the value going down because in this iteration we are adding minus 400. And so 250 is 650 minus 400. Okay, so in the last iteration, the value is 2540, and then adding 1300 will eventually result in this value here. Great. So this is really how the reduce method works. And I think this log here is a great visualization of that. Let's give it all the space we need. And let me just change this one here to 100 so that you see the effect of changing this. And so now we can expect this accumulator in the beginning being 100. And so we already start with a small snowball here, which then we keep adding to. And therefore, our final balance is now 100 euros, or whatever it is, larger. Okay? And yeah, let's one more time do the same thing manually, basically with a for loop. So of movements. And so we need one more time an external variable here, which is going to be the sum. Let's call it balance 2. So balance 2 starts at 0. And so essentially this is our initial accumulator value, just like this 0. And then sum plus equal the current movement. And if we log balance 2, we will get, okay, now of course, this has to be balance 2. But now we get indeed the same result. And so here you can see this common pattern that we always need an external variable whenever we want to use a for loop. And that's fine if you only need one loop, but it starts to become really cumbersome and unpractical when we use many loops for doing many operations. So these methods that we've been studying, they completely avoid this extra variable, and they simply return the variable or the value actually right away. All right. And of course, we can write this here in an even simpler way. So using an arrow function, and I will still keep this here so that we can see the return that's happening. So first we can get rid of this. Then we get rid of this. We also don't need any of these. But here we always use or need the accumulator and the current value. So here we need parentheses, then the arrow, and then, as always, we can get rid of all of this. And so now still our balance is the same. Awesome. So understanding how the reduce method works is something really important, but it's also way more confusing than the other ones. But I'm sure you're well underway of really understanding it. And now that we know how it works, we can actually now also calculate the balance of these movements here, and then print that balance right here to our application user interface. And so let's go ahead and do that here. So finally back to our application here. And so let's do that down here. So calc and print balance. And so this function here will once again receive the movements as an input. So any array of movements will work. And so now let's calculate the balance based on this array. And essentially this is exactly what we wrote before. So that's movement dot reduce, but it doesn't hurt to write it here again. So remember, the first parameter is now the accumulator, and only the second one is the current value. So let's call it the movement now. And so here simply we return the accumulator plus the current movement, and we start at 0. Great. And now all we need to do is to display it here in this element. So let's check this out. And it is called the balance value. And just like before, I already have it selected here. And this is a label. So balance value is here. So I called it label balance. And so label is basically all the things where we simply want to put some text in. All right. So let's say label balance dot text content, and this one we already know, equals the balance. And let's actually do a template string here, or a template literal, and also display the euro sign. Well, I don't know where it is, so let's just write EUR, which also means euro. And so now, let's see. Of course, we didn't call the function yet. So let's do that here as well. And actually, let's put this function here where it makes a little bit more sense, because it kind of belongs to this display movements here. Okay, so let's actually also call this one here calc and display balance. So to give it a similar name as that one. And so now I'm going to call it calc display balance. And once again, I'm calling it with account 1. So account 1 dot movements. And then later on, as we keep developing this application, of course, these movements here that we're going to use will be from the account that logged into the application. So if Jonas logged into the application, then Jonas's movements will be shown and Jonas's balance. But if Steven logs in, then of course Steven's movements and Steven's balance will be shown here. And right now we already see our balance up here. And so this actually happens to be exactly the same we calculated before. So also 3840, because the movements are indeed also exactly the same. Great. So that's beautiful. With this, we actually already completed some parts here of our flowchart. So let's also keep this one handy here so that we can keep looking at it. And so we already did calculating the balance and displaying the balance. So we did all this in just one function. And we also already have displaying the movements. So indeed, we are making some nice progress here. And the rest that you see here will be even easier as we go on. Now, just to finish this lecture here about reduce, let me show you one final example, because we can also do other stuff than just adding up values. That would become boring at some point, right? And so we can also do other stuff. So this time what I want to do is to get the maximum value of the movements array here. Okay, so in this case, the result we're looking for is this 3000. Okay, and so for that, we can also use reduce, because remember, reduce is for boiling down the array into just one single value. But that value can be whatever we want. So it doesn't have to be a sum. It could be a multiplication or even something completely different, like a string or an object. But here we will keep working with numbers, but this time we want the maximum number. So let's kind of go manually through this array to determine what the reduce method should do. So let's start here at 200. Is this the maximum value at this point? Well, we don't know yet because we just started. So let's save 200 here mentally as our current maximum. Then we move on to the next value and we see 450. So is this greater than our current maximum, which was 200? Well, yes, it is. It is greater. And so 450 is now our current maximum. Then minus 400 is of course less than our current maximum. Then we move on even further. So 3000, is it greater than our current maximum? Yes, it is. And so that becomes our current maximum. So we store this 3000. And then we keep going through the array. And as you see, there's no other value greater than 3000. And so in the end, our maximum was this one. So 3000. Okay. And now all we need to do is to essentially translate this into code using the reduce method. So let's call it max movements.reduce. And as always, we need the accumulator and the current value. So I'm calling it movement here again. All right. And now this time, what should be the purpose of this accumulator value? So that's always the big question that we have to ask when we use reduce. So up here, when we wanted to add all the numbers together, the purpose of the accumulator was to keep track of the current sum. And so here, the accumulator will be the one that will keep track of the current maximum value. So let's just start by writing the logic here in a bigger way so we can understand what's happening. And then I will simplify it to make this a one-liner function one more time. So translating the logic that we just went over here is to say, if the accumulator is greater than the current value, which is the movement, then return the accumulator, right? Because in the reduce method, we always have to somehow return the accumulator to the next iteration. And in this case, we simply want to keep the accumulator at the value that it already is and not change it. Okay? We want to change it in the other scenario, basically. So when the current value is greater than the accumulator. So that would be this case here. So here, remember, the current value is 450, but the accumulator is 200. And so now the movement is greater than accumulator. And so what we want to return here as the accumulator in the next iteration is the current movement. And so that's it. Okay. And now we also need the initial value. And so the initial value makes sense to be this first value here of the array. Okay. And so that's movements at position 0. Now we could have used 0 here, but that would not be correct. Because imagine that the first value would be like negative. Then this might not work as expected. Maybe it might work with the maximum, but not with the minimum, for example. So don't just put 0 here when you're trying to find a maximum or a minimum value. Always just go with the first value of the array. Okay. And that's it. Let's see if it works. And then we can maybe go over this again. So, indeed, we get 3000. So, we started at 200. So, in this iteration, is the accumulator greater than the movement? Well, it is not. And so, return the current movement. Okay, but the first iteration is not that important. It gets interesting here in the second one. So now our accumulator is at 200 and the current movement is at 450. So this one here is false again. And so now we return the movement as the new accumulator in the next iteration. All right. And so in the next iteration, that accumulator is 450 now. Then here, the current movement is minus 400. And so here is 450 greater than minus 400? Yes, of course it is. And so let's simply return the accumulator so that it stays the same in the next iteration. And so that's the logic all the way until the end of the array. And with this, we then end up with this maximum value. All right. So I hope that made sense. And in fact, there is a ton of things that we can do with this reduce method. It is by far the most powerful array method that there is. And because of that, it can also be the hardest one to use. So we always need to think exactly what we want the accumulator and the current value to be and how they should interact. But I hope that with this exercise here, I could demonstrate the thought process a little bit. And throughout this section and the rest of the course, there will be some more exercises of the reduce method so that you can also learn better and better how to use it yourself one day. This is coding challenge number 2. And in this one, we're going to go back to Julia and Kate's study about dogs. And this time, they want to convert the ages of the dogs to human ages and then calculate their average age. So your job is to create this calcAverageHumanAge function. And this function accepts an array of dogs' ages, and it does the following 4 tasks. Or actually just 3 tasks. So first, calculate the age of all the dogs in human years using this formula. So if the dog is less or equal to 2 years old, then the human age is simply twice the dog's age. But if the dog is older than 2 years, then the human age is calculated by this formula. All right? Then, in the next step, exclude all the dogs that are less than 18 human years old. And that is essentially the same as keeping the dogs that are at least 18 years old here. Okay? Then, finally, calculate the average human age of all the adult dogs. And from the other challenges, you should already know how to calculate averages. Now in this one, you will do it in a different way, hopefully, because the goal of this challenge is, of course, to use the map, filter, and reduce methods. Finally, then run this function for both these test datasets. So as I said, this is a way of training the map, filter, and array methods that we just studied earlier. And so good luck with this challenge. Take all the time you need, and I see you here once you're ready. So, were you successful in solving this one? I sure hope so. And in case there was some doubt, here is my solution. So, this function takes an array of dog ages, and then we want to convert all of these ages to human ages. So what we want here is to create a new array based on the original array. And so for that, the map method is perfect. So we will have a new array called human ages, and that will be the result of calling the map method on the ages array. Then this callback function gets access to the current age, so the current element in the array. And now here what we need to return is the result of this formula. So this one here. And so let's write a ternary operator here. So if the age is less or equal to, then what we want to return here is 2 times the age, right? Because that dog age is of course this age variable here, because it comes from the ages array, which itself is an array of dog ages. Anyway, if the age is greater than 2, then the result will be 16 plus the age times 4. And so, since this has an implicit return here, remember it's like writing this here, okay? And so it's returning either this value here, or actually either this value, so twice the age, or 4 times the age plus 16. So that's the callback function, and this will then produce the array that we're looking for. Let's take a look. So human ages, and then we just need to call the function. And so here is the age converted to human ages. And it does indeed look correct. So let's assume it is correct. Then, next up, we want to filter for all the dogs that are at least 18 years old. And so that will then exclude all the dogs that are less than 18 years old. So that's going to be the adult dogs. And so that is human ages. And now we use the filter method. And that makes sense, right? Because it's the filter method who allows us to set a condition like this one. So when the age is at least, so greater or equal 18, then put it in the new array, which will be the adults array. And so let's log that one as well. So actually I want both of them here. So human ages and the adults. And so indeed, these two here, the 4 and the 2, are gone. All right. And now finally, we want to calculate the average. Okay. And so the average is basically adding all of these values together and then dividing the result by 5. So the length of the array. So that's essentially what we already did before. So that's going to be adults.reduce, then the accumulator and the current age, and we want to return the accumulator plus the age, and the start is going to be at 0. So this here will return the sum, so all of these ages here added together. And so now all we need to do is to divide this by the length of this array. And then we simply want to return this average value that we just calculated. So let's just see if this makes sense. Let's actually save it here in a variable instead of logging it directly. So average 1, and then also average 2. And then just log both here to the console. And all right, here they are. And this looks pretty reasonable to me. And so our solution here works. Now, I just wanted to let you know that we could have done this average calculation here in a different way. So in a bit more complex way. So let me show you one property of an average. So let's say we want to calculate the average of 2 and 3. So we do that by 2 plus 3. So we add all of this together and then divide it by 2 because we have 2 values. And so that is then 2.5. However, we can also do it in a different way. So we can divide both of them by 2 immediately. So 2 divided by 2 plus 2 divided by 3. And this will also be 2.5. So these here are essentially the exact same thing. Okay? And so here we can do this differently. So let me actually duplicate this line so that we can keep both here. So what I mean is that we can actually simply divide the current age here immediately by the length of the array. Right? Here, this is actually 3 divided by 2. Okay, sorry for that mistake. And so what we did here was basically to divide both of the values always immediately by the 2. And so that would be the same as immediately dividing the age here by the length of the array. So dividing this by the length of the array. And now remember that we can get this length immediately here from this parameter. Well, not really the length, but the array itself. So that's the 4th parameter. And so now we can say array.length like this. And so see what happens now here. And indeed, the values are exactly the same. And so this way of calculating it is just the same as this one here, but we can do it kind of all in one line. And I also wanted to show you a good use case for using this array here. In this case, we could of course also just have written here adults.length, but sometimes when we chain these methods together especially, then this is the only way we have of using the current array. And we will see a use case of that later. Now, of course, I did not expect you to write it like this, but I just wanted to show you a good use case for the current array parameter that we have here. Okay, and with that, we finished the challenge, and I see you in the next video. So up until now, we have been using the map, filter, and reduce methods kind of in isolation. However, we can take this one step further by chaining all these methods one after another. For example, let's say that we wanted to take all the movement deposits, then convert them from euros to dollars, and finally add them all up, so that we know exactly how much was deposited into the account in US dollars. Okay? Now, we could of course do each of these operations individually and store each result in a new variable. However, we can also do it all in one go. So let's do that. And I will start here with the filter method. So as I said, we want to take all of the deposits. So we get the movement here, and then we filter only for movements that are positive. And so only these are the deposits. And so the result of this operation here will be a new array. And so now we can call map on that array. So here again, we then get a movement. And now we can convert that movement to US dollars. So we can do that with that variable that we used before. Let's see where that is. So euro to USD. So movements times euro to USD. And so with this, we converted all of the deposits to US dollars. But now we can take this even further, and on this result, we can also call a reduce. And of course, we could also call more filters or more maps. But now let's just do a reduce here. And so basically add all of these values together. And so we already know how that works. So accumulator, and then the current movement. And we just need to return accumulator plus the current movement. So that's movement and 0. And so now let's store all of this into total deposits in US dollar. Okay, so you see that we did 3 data transformations here all in one go. So let's log it to the console to see that we actually get a result here. And yeah, we do. So this is the deposits that we did into our account in US dollars. And as I mentioned, we could of course change many other methods here as well, as long as they return new arrays. So filter returns a new array, so we could have added something else here, or the same goes for map. But reduce, for example, will return a value. So only this number in this case. And so of course here we could now not have chained a map or a filter after this. So we can only chain a method after another one if the first one returns an array. So you can imagine all of this as a sort of pipeline that processes our data. So we put data in at the beginning, which is here, and then it goes through all these steps. So in this case, these 3 steps here, and then in the end, our input data comes out processed on the other side of the pipeline. So let's just write this here, because I think this is a nice analogy, right? Now, when we chain all these methods together here, it can be a little bit hard to debug if one of the results is not what we expect. For example, if this result here would be something really weird, we wouldn't really know from which step of this pipeline it would come from, right? And to solve this, it would be good to check out the array in each of these different steps. So let's say we did a mistake here and we wrote it like this. And so our result would come out negative, and that would be strange. So in this case, it would probably be like to know the result of this filter operation. And so we can do that by using the array parameter that we get access to in this callback function. Remember? So we have the current element, the index, and the entire array. And actually, let's duplicate this here first. Okay, and set this back to what it was. Okay, so let's now log to the console this array. And so now we need these curly braces because we will have a code block, and we need to actually return our calculation here. But anyway, we can now take a look at the whole current array that this map method here is being called on. So let's take a look. And so indeed, it is this array of the 3 negative movements. So let's log the movements here one more time. So you see that indeed we get these 3 negative movements now. And so that is the result of this filter here. And so again, if we want to see that result of only this operation, we can check out the current array in the next array method that is chained on that filter. And so in this case, it's the map. And so this is one of the great use cases of having access to this current array. Because as you see, of course, this array has to be the result of the previous operation, so of this filter. It is not this initial movements array, because that's not what we called the map method on, right? The map method was called on the result of movements.filter. And therefore, that is the value here of this array. That makes sense? Now it was of course logged here 3 times because this callback function here is called 3 times. So once for each of these 3 values. Okay, so let's put it back to what it was. And now we get the correct array. And this one is now printed 5 times because there are 5 values in the array. So let's just turn this one off here as well. And so this was just to show you that we can inspect the current array at any stage of the pipeline using the 3rd parameter of the callback function. All right, and so now that we know how this chaining works, we can go back to our application here. Let's give us some more space. And we can now calculate these statistics down here. So that's all of the deposits. So incomes here basically. Then we have the outcomes. So that's the sum of all the withdrawals. And then also an interest that the bank might pay us. And so let's go back up here to the application. And so we already have display movements, calc display balance. And now here I will create another function called calc display summary. And just as our previous function here to calculate the balance, this one also receives the movements data. And so we will also call it with the account1.movements. And once again, we will then later change this to the user that is logging into the application. Okay, so let's start by calculating the incomes. So that's this first value here. And so that's all the movements. And then we filter them for only the positive ones. And so this is now exactly what we did before. So greater than 0. And now onto this one, we simply chain another reduce. Because now we want to add all these positive numbers together. So there's no mapping involved here. It's just filtering and then adding together. Give it a save, and now we can put it here inside of this label. So this HTML element. So it's always a good idea to check out the name of it. So this one is called summary value in. So as before, I already have that here. So it's this one, and it's called label sum in. We will also then need label sum out and label sum interest. So keep these in mind for a bit later. So here we have label sum in, and then our old text content property. So in comes, and then the euro sign. And now I know how it works. At least on Mac, you can use the emoji picker. And then you just search for euro, like this. And here you go. And I'm sure there is something similar on Windows as well. Let me actually copy it and put it also here instead of this euro. And the same also here in this movement. So here where we display all the movements so that the euro sign also appears here on all these. Okay, this should now already be working. So let's give it a save. But nothing happened here. That's because I am calling the wrong function here. So this has got to be summary. So I was calling calc display balance for a second time. Now it works. So that's 5,000 euros. And you see that also now here we have the euro sign, which makes it look a little bit more like a bank application, right? And now here the same for the outgoing money. So we're going to calculate a variable called out. And now I want to leave this one here again as a challenge for you. So that's a very simple one. Just don't look at the rest of the code. And I'm sure you can do this one without any problem. So that's just movements dot filter. And so now it's basically just the opposite. So the negative movements. Okay, and then label sum out, set to out, and that did not work. I see we have an error here, and so assignment to constant variable. No, I see we are forgetting here the text content property. Maybe you saw that coming. And now it works here beautifully. Okay, now I just want to get rid of this minus sign here. We already know that the money is going out, so there's no need for the negative sign. So let's just take the absolute value here. So we did that before. So math.abs, and this is going to remove the sign. Yeah, beautiful. Now finally the interest here. And so let's say that this bank pays out an interest each time that there is a deposit to the bank account. And that interest is 1.2% of the deposited amount. Unfortunately, in the real world, it's nothing like that. But here in our fictional bank, we can do whatever rules we want, right? So as I said, the interest is paid on each deposit. So first we need to get these deposits. And so that's this filter here. We just copy it. Okay. And so now on each of these deposits, we will receive 1.2%. So what do we do here? Well, we're going to create a new array which contains all of these interests. And then in the end, we can just add them together. And so map is the way to go here. So we take the current movement, and we could even call this here a deposit. Let's do that. We know that this has to be a deposit, and so let's call it that to make it a bit more explicit. We could do the same here, but that's not necessary. So we get 1.2%. So we multiply this by 1.2 divided by 100. So that's how you calculate percentages. And then finally, we just add it all together. So let's just take this one here, chain it here. And now each of the current elements is no longer a movement. So let me just call it here an interest, so int. All right. And now let's also just copy this one here. So label some interest. And then here, of course, it is the interest. And you see, we got 60 euros and 24 cents of interest. Great. But now let's say that the bank introduces a new rule. So now the bank only pays an interest if that interest is at least 1 euro or whatever other currency. So where do we put that in our calculation? So again, only if one interest is at least 1, only then it will be added here to this total. And so this sounds like it's got to be somewhere between this place where we actually calculate the individual interests and here where we then add them together. So let's add a new method here in the chain between the map and the reduce. And it is going to be a filter, because we basically want to exclude the interests that are below 1. So this one here is an array of interests. And actually, let's take a look also at the current array here. So interests, then I, which we're not going to need, and the whole array. And so let's log to the console the whole array just to see what's happening. But anyway, what we will have to do here is to filter the result of calling these interests here for values that are at least 1. So interests greater or equal 1. And only these interests will make it into the final calculation. So into the next step here of the pipeline, which is this reduce. So you see that the interest now decreased a little bit. And that's because indeed here in this array of interests, we have one value that is below 1. So this 0.84. And therefore, it will get filtered out in this new step that we edited here to the processing. And so then the final interest that's going to be paid by the bank is only these other 4 values added together. So these 3 plus this one. But this one here has been excluded. All right, that makes sense. So anyway, this was another great part here of our Bankist application. So with this, we now also completed this part here. And hopefully you can start to really appreciate the huge advantage that working with these array methods gives us over simply working with more traditional loops. And now just to finish this lecture, let me just give you a couple of remarks about chaining. So first, we should not overuse chaining. So we should try to optimize it, because chaining tons of methods one after the other can cause real performance issues if we have really huge arrays. So if we have a huge chain of methods chained one after the other, we should try to compress all the functionality that they do into as little methods as possible. For example, sometimes we create way more map methods than we actually need, where we could just do it all in just one map call. So when you chain methods like this, keep looking for opportunities of keeping up your code's performance. And second, it is a bad practice in JavaScript to chain methods that mutate the underlying original array. And an example of that is the splice method. So again, you should not chain a method like the splice or the reverse method. I mean, you can do that, and for a small application like this one, it's not a big deal and it's not going to cause problems. But in a large-scale application, it's usually always a good practice to avoid mutating arrays. And we will come back to this when we talk a little bit more about functional programming. Anyway, with that being said, there is now another coding challenge waiting for you. Welcome to coding challenge number 3. And this is going to be a quick and easy one. So all I want you to do is to rewrite the calc average human age function that we wrote in the previous challenge. Now the difference here is that this time you should use an arrow function and you should use chaining. Now to make this chaining work, just keep in mind the second way that I used in the last challenge to calculate the average. Then, as always, use this test data here to try out your function. And so I see you here in a minute or 5 minutes maybe once you're done. All right, so let's grab the code here from the previous one. So there's no need to just rewrite everything. So let's get rid of all the comments here, all the console.logs. And so let's save it here and then rewrite it as an arrow function. So it still takes in the ages. And now what it returns is simply the ages, then dot this map. So calculating the human ages. Okay. And then on the result of that, we filter for only the adult dogs. So when the age is greater than 18. So this is what we have for now. Let's call this one here 2. Okay. And so for now, this is the 2 arrays that we have, one for each function call. But now let's then also calculate the average. And so for that, all we need to do is to chain this method of calculating the average that I showed you in the last lecture, or actually in the last challenge. So pasting that here. And so now we get the exact same results as before. And that's actually already it. Now, what's really important to notice here is that this is actually really the only way of calculating the average now. So basically dividing the age by the length of the current array immediately here in each of the iteration. So remember that in the last challenge, I first simply added all the values together, and then afterwards I divided it by the length of the array. So in this case, by the length of the adults array. However, that would not work in this case, because there would be no way of knowing the length of the adults array. So of this result here, right? Because we haven't stored it anyway, and so we couldn't do like this, like adults.length, right? This wouldn't be possible because adults here does not exist anywhere. And therefore, we need to take that length from this input here. So from this fourth parameter, which gives us access to the array on which the method is called. And that's the reason why I showed you this way here in the last lecture. Because, yeah, again, this is the only way in which we can now calculate this average. Unless we wanted to do it in 2 steps. But my instruction here was to really do it all with chaining. And so this is the way to go then. All right. So make sure you understand really why, and also how this one here works. And then let's already move on to our next method, which is going to be the find method. So another really cool one. So I can't wait to see you there. After the very important map, filter, and reduce methods, we still have some more methods to learn, which are also super important and used all the time. So in this lecture, we're going to talk about the find method. So as the name says, we can use the find method to retrieve one element of an array based on a condition. So let's again use our movements. And so find, and just like the other methods that we've been talking about, the find method also accepts a condition. And just like the other array methods we've been talking about, the find method also accepts a callback function, which will then be called as the method loops over the array. All right, so find is basically just another method that loops over the array, but then it does something different. And in this case, what the find method does is to retrieve an element of the array. So as always, the current element of the iteration is the movement, and then here we specify a condition. So let's say movement less than 0. So basically, this is here a withdrawal, right? So a negative movement. So you see that just like the filter method, the find method also needs a callback function that returns a Boolean. So the result of this is of course either true or false. Now, unlike the filter method, the find method will actually not return a new array, but it will only return the first element in the array that satisfies this condition. So basically, in other words, the first element in the array for which this operation here becomes true. And so basically this here will return the first withdrawal. So first withdrawal is this. So let's log the movements again to the console. And then let's also log the first withdrawal. And so indeed, minus 400 here is the very first value that appears in the array that is negative. Okay? So, as you see, the find method is a bit similar to the filter method, but there are two fundamental differences. First, filter returns all the elements that match the condition, while the find method only returns the first one. And second, and even more important, the filter method returns a new array, while find only returns the element itself and not an array. Okay? So make sure that you understand this fundamental difference. Now, this example here is not really exciting, and so let's now take it to the next level and start actually working with our array of objects. So that's this accounts array, remember? So this array which contains the 4 objects where each of them is one account. And as I mentioned earlier, this is a pretty common data structure in JavaScript. And so let's now work with this together with the find method. Because in this context, the find method actually becomes really useful. So that's because using find, we can now basically find an object in the array based on some property of that object. And so that's really cool. So let me show it to you. So let's create a variable called account, and it's going to be accounts. So all the accounts dot find, and then our callback. And so as we loop over accounts, each of the current elements is one account. Okay. And so now let's say we want to select one of the accounts by the name. Now this disappeared here, so let's bring it back. Okay. So let's say we want to get the account where the owner is Jessica Davis, right? So we can simply do account.owner equals Jessica Davis. So let's see. Just the account. And indeed, we get now only this object. And this is really, really powerful of arrays and objects. So where one array contains multiple objects, which all have a similar structure. So all of them here have an owner, have a movement, a pin, a username, and so on and so forth. So using the find method, we can then search this array basically to find an object that matches a certain property that we already know. So in this case, that property that we know is the name. All right. And so we simply compare Jessica Davis here with the account owner. And whenever this condition here is true, well, then that object is returned. So usually the goal of the find method is to just find exactly one element. And therefore, we usually set up a condition where only one element can satisfy that condition. And so that's why we used the equal operator here. Okay, so if the owner names are unique, then this equal operator here will only ever match one account with this name here. All right, and we will actually use this in the next couple of lectures to implement the login feature and also some other features. Now, I'm going to leave it to you here as a challenge to implement this functionality using the for-off loop, just like we have been doing it with some of the other methods, like map and filter. So we have also been implementing these using the for-off loop just to see the difference. But now I'm not going